welcome to my channel. It's been a little while, but today I'm coming out again with a new video. Maybe you know this, maybe you don't, but I'm a long time F1 fan and I'm a big F1 fan and I'm an engineer, so the technical side of F1 really draws me in. I'm a mechanical engineer that specializes in vehicle integration and yeah, I really like aerodynamics as well. If you know my channel, you know that I design vehicles, again, based on aerodynamics, and so aerodynamics has me really intrigued. But in the combination of vehicle design, packaging, safety, that sort of stuff. I've now watched several videos on the RB20, the new Red Bull car, and when I look at them, I feel like they're all missing a point. A lot of people calling it a Mercedes clone, for example, which in my opinion it is not. It is absolutely not. So in this video I want to try and explain what I think is happening, and I'm going to make a couple of simple drawings to explain this. So let's dive into it. So what I've done here is made a top view section of basically the center of the vehicle. So this would then be the inlet box above the engine, this would be the halo going into the cannons, and this would be the side pod design with the undercut line here, and then the actual floor edges going to the diffuser. So this is the diffuser and this is the nose. So what I will be doing is I will be slicing it basically into sections, and then in the end make a 3D drawing of everything to show you just what I think is happening. So the first slice we're going to make is the airbox, the second one is next to the monocoque basically, and then a cross section through the side pod, and then an integrated 3D drawing. So looking at the airbox, the design is simple. I'm not going to spend much time on this, but let's say this is your general engine inlet at above the helmet of the driver basically. And yeah, what they do here is basically the air comes in at a high speed and it wraps around the edges going in and then expands here to get the velocity down, and it goes into the engine. So that part isn't really difficult, and that is not really something special. It's just what it is. The only thing that we can say is that with the Red Bull it has been enlarged, and that leads us to believe that more cooling is required from the top because they restricted other parts. Okay, let's go to the second part. So the second part is basically next to the monocoque. Now a lot of people say it is a Mercedes copy, which in my opinion it's not. It is actually a Ferrari copy. It is an S-duct and it's not a zero side pod design. So when you look, you have the monocoque coming in, and then they have this little inlet, something like this most likely, and then you have the undercut going on. So looking in side profile, and remember that F1 obviously had a lot of different types in this, thinking about the F duct and the S duct, where they are trying to push air through somewhere and get it out somewhere else. So basically we have this vertical inlet, and then it most likely comes up somewhere else. And I'm gonna draw it like this, and I will explain that later. And where does it come out then? It comes out in the cannon on top of the bodywork. So that cannon that you see actually is part of the S-duct. So you would have your halo over here. So here is your cabin, your halo, and then your halo rests here somewhere. Yeah. So that is then your halo, and then your cockpit going forward with your nose. So, and the reason why they would do that is that when you look at the airflow coming off the nose, it throws a lot of vortices. So this air, you know, you would have a boundary layer here, and you have the vortices. And basically you're scooping all this dirty air up and transporting it out and away. And Ferrari would have this open, so it joins the airstream. But I think that Red Bull, to keep the airflow nice and clean, puts it in the cannon and transports it out. There is a little louver system here as well, well, the other way around actually, but maybe they allow the S-duct to escape there. But this is what I'm thinking they're doing. They're cleaning up the airflow next to the monocoque. And in the 3D model that I will draw later, I will explain why I'm thinking they're doing this. Okay, let's go on to the third section, which is the sidepod inlet itself. So again, this is the inside view. So now if you look at the sidepod, basically what they've done, they do like you call an overbite on the sidepod. So it's extended forward, and then the sidepod itself dips down. And then you have this massive undercut that they have been realizing. Now, what are they doing in this section? Well, what I think they might have done is they might have gone for something that that is new, I think. A packaging thing that they've done. So, what is that? What I think they've done is they create a wing shape here. So this part creates downforce. And they kept it very, very small. So this is basically the shape of the sidepod. And what they are doing, I think, is they're able to allow the air to come in, and they're channeling it over the radiator. But not any type of radiator. I think that their radiator actually works a little bit different. I think that the top of the bodywork initially acts as a shroud, and that there is a channel, and I'm drawing these blocks on top here, and I will explain a little bit later what that means, in my opinion. So what I'm thinking is that they are creating a shroud like you would see on an industrial electric motor. So if you have an industrial electric motor, you will have something like this. So you have here an intake with a fan behind it that spins, and then the shroud is actually pushing that air over cooling ribs. So you have all these cooling ribs here. So the air comes in, and is pushed over these cooling ribs to cool the motor down and the windings of that motor. And I'm thinking that because Red Bull has this incredibly high velocity air going over, and this inlet is so incredibly small that you can hardly see it, they want this air to keep that velocity, push it through this maze of cooling fins, and then, as we all know, the hot air is going up and out via the cannon. Because obviously hot air wants to go up. So now you have the S-duct, which is behind here basically. So you have the S-duct, the Ferrari type S-duct here, that basically takes all the dirty air that is here and throws it into the S-duct up here. So what Red Bull is trying to do is they get rid of all the wake and the vortices and the boundary layers, the slow moving air, and they're trying to capture all that high speed moving air, and with just a tiny inlet but with very powerful air, they are forcing it through at high speed over a radiator, but not a regular radiator, a radiator with cooling fins. And they're forcing it over the cooling fins, and as it done his job, the hot air, it rises up underneath the bodywork into the cannon and exits out the back. To further, and now we're going into the 3D view, to further basically explain this, there's a third factor that comes into play in my opinion. So we're gonna look at this. We're taking the nose section of the Red Bull or any other car, doesn't really matter obviously, and you have this round edge on the monocoque, and then you get your bottom, and then you have your floor where the bottom is the bottom of the driver is basically, and then you go into your floor. And then you have your board basically pushing that air out. And then another thing that you can clearly see in the range shots, for those who've seen the range shots on Silverstone, is this: in the rain you could see a very, very powerful airflow coming off these things that threw the water up like this. It was very interesting to see. So anyway, so this is the nose, and then we have our halo coming up here, and it goes into the cannon section, and that dips down. Okay, then we have obviously headrest, and then we get the inlet box. So this is in 3D for those you don't know, and then we get a small fin at the back. Yeah, so then we get that overbite style side pod that the Red Bull has. With the water slide. And then we have this little step here with the S-duct. And then it continues on with that undercut. And the undercut goes out like that. And then we have this little step here in the back of the floor that they have, and I want to talk about that as well. And then something else here that I'm going to talk about as well. Okay, so as I've been mentioning, the air spooling off here has a lot of vortices, and on surfaces you have a boundary layer. So this is all. So for those who don't know, basically with aerodynamics, as air flows onto a surface, we assume that the speed is 0 at that point. So the layer that flows on top of it, which is the boundary layer, that has a very low speed airstream basically. So the air that comes over that is the high speed air that you want. That is the air with a lot of energy into it. So yeah, I'm just gonna finish up here the monocoque a little bit better. So you can see the headrest here, yeah, and then you have your front window, well, whatever they have here, you know. So that's then basically our monocoque with the halo and blah, blah, blah. Okay, so we have this boundary layer, we have the vortices, and they all go into the S-duct, as I'm saying. And then through the S-duct, they come up into that cannon that we spoke about. So that is your first part. Now, something else I've noticed that no one talked about is that Red Bull is raising their diffuser. So this is your floor edge, so your throat of the diffuser on the front. They've raised it to the outside. So what you're basically getting is a channel where they are forcing this air through this channel for the outwash and to go around the side pod. And again, this leads me to believe that they want this high speed airflow in this section. And again, they are cleaning up with the S-duct this dirty low energy air that they don't want. And they have now this incredibly fast moving air that comes onto the side pod and moves over it and goes onto the floor and exits the car via the beam wing. And then also they have this incredibly fast moving air underneath here, under that wing profile that I just sketched, to allow it to go into that radiator that they have. And again, as mentioned before, the hot air then exits into the cannon. And then the same basically happens with the airbox on top. Air comes in, does what it needs to do, and then rolls up and joins again into the cannon. And then in the center, obviously, you have your exhaust pipe. So I think they're using the cannon to basically gather all that hot air. That's also why it's so separated from the rest of the bodywork. So obviously you will get, as a lot of people have been talking about, cockpit losses that will come out and spill into this trench that is behind the cannon. But in the actual cannon, they, I believe, are capturing all that hot air. And so you get this dirty air that they're capturing from the S-duct. You get high-speed air into the side pod over that radiator with what I think is like cooling fins, and they are cooling that. And then that hot air also rises up into the cannon and exits out of the cannon as well. And then with that trench that they've put here in the floor, they're really forcing all this air to go follow the side pod. And as we could see in the range shot, is that they have a very good outwash at the side of the car here. So if you watch that video of the range shot on Silverstone, you could see the spray really coming out of the side of the vehicle like a meter high. So I think that that part is also really important. Now, remember when I drew the S-duct that I didn't had it go all the way to the bottom. So again, this is that S-duct. And what I'm thinking they're doing as well, if you remember the old S-ducts that were in the nose and the F-ducts, I believe they also had in the past, is that they allowed air to go straight through and exit somewhere else. And if you look at the side pod, at the rear of the side pod, you have this weird end, and I want to talk about that as well. And then right behind it is a little exit that they've made. So I'm thinking that part of the S-duct goes into the cannon and part of the S-duct actually exits out the back. And that is then basically like an F-duct, or a more traditional F-duct that they had in the past. Okay, now another thing, and this Kyle Engineers goes into this as well. Kyle Engineers is a YouTuber. He was an ex-automotive F1 aerodynamicist, so he knows what he's talking about. One of his videos was about the diffuser, and what they did with the diffuser basically was that they introduced a step into the diffuser like so to control the pressure. And I think Red Bull is doing something similar with their side pod. They are allowing dirty air to come off and gather here and allow the fast moving air to flow over. That is, I think, another step that they've done here. So this is your floor edge, this is your bodywork coming down with a steep edge, and then you have your diffuser coming out. So basically on the diffuser we already know that they are doing it. So there's air collecting here so that faster moving air can go over. And I think Red Bull is doing that all to power the floor and to create rear downforce basically. More floor control, more stability in the rear. So I made the sketch again to have it look a little bit better. So again, we have the S-duct taking in the air, putting it into the bazooka and going out. We have the engine airbox at the top doing its thing. And then, as we said, underneath this part here, we have an intake that goes into the radiator. And then we have this trench that they're trying to create here to help promote a high-speed airflow in here. And obviously in front here we have the pull rod suspension that also allows this powerful air to flow directly onto the side pod. Then we have this little outlet here that I believe is part of the S-duct that allows air to go straight through the chassis. And then we have the divot here at the back, which is now not really shown, which allows again to catch the dirty air and allows the high speed clean air. So the boundary layer and the vortices will stay in this pocket basically, and then the high speed air can transfer over it. Now there's another thing that I think they're doing, and it's a two-part thing where what you see, and this is for those of you who don't know, the regulations for this new era were to determine that the airspeed on, the wake and the air coming off the cars would be cleaner to allow cars to get closer and allow cars to overtake. Now what you've seen is a lot of cars getting back to cut out wingtips, like so, at the back on the rear wing. And this is something that I think F1 didn't intend to happen, because one of the reasons we are with this rounded style of wings is that it shed much less vorticity, and therefore the air behind the car is much less dirty. It was, I believe, something between 18 and 30% better airflow coming off the rear by introducing these rounded corners on the wings instead of having the square corners. But what Formula One is doing right now is they are cutting basically this part out, and that allows you to have sharp corners again, shedding a lot of vorticity and thus creating dirty air. And what I'm thinking that Red Bull is doing is that, first of all, they have this cutout on the top element of the rear wing, creating dirty air to allow other cars to not follow as easily. And the other thing is that with the bazooka, with the cannon, they are doing the same. So the cannon basically drops down like so onto your beam wing. However, this creates such a steep angle of attack that the air won't be able to basically stick. So the air will basically start doing here something like this. So you get a big wake, you get disturbances, and so the air moving over the top plane of the wing is very powerful. But the air coming off the wing, it attaches basically. And that in combination with this creates a lot of dirty air on the back of the car. And I think that Red Bull has created a car that is super efficient with the airflow over the car, but as soon as it leaves the car, they create a lot of dirty air so that other cars cannot climb into their wake and cannot get close as the rules intended to. And therefore I think that Red Bull will be extremely fast and extremely competitive and extremely difficult to overtake. And Mercedes has been trying, and a lot of teams with that cutout, they're trying to do the same. They're trying to make the air behind the car, as soon as they're done with the air and the energy of the air, they're trying to make the air dirty again, to basically make it more difficult to overtake, to get close. And I think with this style, what Red Bull is doing, they're taking it to the next level. So last year, obviously, they used the beam wings to enforce their DRS effect. And this year, they are using it to disturb the air behind the car to basically be the fastest and also be very difficult to overtake. That's what I'm thinking is happening here as well. It's a little bit more to it than I think most people have explained so far. And let me know what you think. But yeah, that is basically my analysis of this new Red Bull, and I'm really looking forward to seeing it. And as some people noted, it might be a little one of the fingers up to Mercedes to see we can make it work, but I don't think that is what it is at all. As I said, I don't think it's a copy of the Mercedes. It's
a copy of the Ferrari S-duct, and then they have a new concept for the radiator, and it allows them to run this side pod in combination. Obviously, Aerodynamic pushes the aerodynamics, and then mechanically they have to follow. So yeah, that is my opinion on what is happening at Red Bull. Yeah, let me know what you think is happening. And thank you for watching. And yeah, I think we all look forward to the new F1 season. And yeah, after testing we'll get a good idea, and after the first race we will definitely get a good idea. So exciting times are coming, and wish you all the best. Thank you.